Come. Good afternoon, everyone. Welcome to our webinar. We will give a couple minutes as I could see a few others joining. Let's start promptly in another 40 seconds. We will start the webinar in another 30 seconds. Good afternoon, everyone. We will start the session in another 15 seconds. All right, folks, let's get started. So good afternoon, good morning, and good evening for all the attendees across the globe. And thank you for joining and keeping aside 45 minutes of your time for our webinar today. I'm very privileged. And today's topic is on AI for intelligent and pervasive test automation. And I'm the speaker, and my name is Siva Prasanna Vanapalli. I have about 16 years of experience in the software testing and the software development areas, primarily testing in the SAP, web services, web UI, CRM, ERP across all different technologies and various domains, has been helping numerous customers, primarily being working for system integrators, and have also extensive experience in the DEVOPS CI/CD. That's been my core skill sets. And in the last 2 years, a little over 2 years, I've been spending quite a bit of time in the AI space, primarily how AI can influence, impact, and improve the quality and efficiency of quality engineering and DevOps processes. With that said, I'm here today to share a lot of knowledge that I've gathered in this space, what is practically possible, and what I have been seeing with various different customers with their implementations. With that said, a quick 30-second obligatory pitch about the company that organizing this webinar. I work for Marlabs, and we are a digital innovation company. We founded in 1996, have about 2,500 associates globally, and we are headquartered in New Jersey, Piscataway, New Jersey, in the USA. But we also operate outside of USA in 4 different countries, 3 different locations in India, in Canada, Mexico, and Germany. And we are a CM level 5 company. We also have ISO 27001 certification also. And we work across all different technologies and primarily known in the East Coast area, but also have good footprints across the USA and Germany for various customers in various domains, offering different set of technologies and application development, cloud, cybersecurity, quality engineering, DevOps, all different technology spectrums. Coming to our quality engineering services, where I am specialized and the head of quality engineering and DevOps, we have about 400 resources globally, and we offer end-to-end services, QA validation services, DevOps, CI/CD, continuous integration. We have proprietary automation and performance frameworks and scripts, security and infra-related COAs, and we work hand in hand, and we help numerous customers doing end-to-end services. And the new thing in our belt for the last 1.5 years is the AI-based test automation, and started doing quite a good number of implementations and have seen a good set of results, which is what we're going to talk about today. Before we talk about today's webinar, I want to introduce you to 2 different webinars that I have done in this year, in 2019, early part of 2019. The first one was about AI-driven transformation of software testing. We have done with our partner Atomic. And the second one was test automation on the fast track with AI that we have done with in association with another partner, Functionize. And on both webinars, we are focused around different challenges that we see in the automation testing and how AI has been helping there. And where we have focused significantly is the demo portion of how these products would work in the real time and various use cases and how in practice, in reality, could those demos be seen, right? So if you are interested, here are the links, recording to those links. Please feel free to go through them, and I hope those will be useful for you. But today's webinar is going to be slightly different. We are not going to show any demo because we have done that in the past. Rather, we are focusing more on the practical approach of AI and leveraging AI in the quality assurance and automation primarily. With a lot of digital transformation going on, it's a big word, quick buzz. And how do we adopt, QA in the world of Agile and DevOps? And how do we accelerate QA with the, keeping in pace with the release cycles? That's been the challenge. And with the arrival of QA, we have done quite a bit of, acceleration in terms of scripting, test automation, and the test data, defect trends, and all that. So that's where our focus. And what's going to be discussed today is primarily different challenges with software testing lifecycle and QA automation, and how do we leverage AI to overcome such challenges, and what are some of the use cases and realistic possibilities with UI, and some common myths and some hesitations to start leveraging AI, and what are some of the common machine learning algorithm and techniques that we use, and how do you get started, and what are the realistic practical results that you are seeing today in the life. So that's where our focus is going to be. Before I get started, I just want to run a quick poll. It will have 2 questions, and each would be about 30 seconds. It's just to set the context and gather your information. So you would see the first question on the screen. You have about 30 seconds. I would request you to respond, and let's see where you stand. The question is approximately what percentage of your test cases today are automated? You have about another 15 seconds. And boom, I think we're good. So I have the quick results here. As you could see, the percentage-wise, about 75%, over 75% is about 18, which is goes in line with what we see in the industry, and under 25 is 40%. So if you can look at it, probably close to 50% is around 25 to 30%. That's the level of automation what we have in the industry today, and this distribution actually reflects a bigger distribution of different customers that we have seen and that we're working with as well. So time for the next question, quick second question. The second one is, what is your primary challenge when it comes to test automation? Fifteen seconds more. Five seconds more. Okay, time up. So if you see the results, about team skills being 22%, and the significant one that we see quite a lot is the frequent code changes. A lot of check-ins and a lot of frequent releases, especially with Agile and DevOps, about 44%. So I hope you see the results, and those are in line with your expectations as well. Let's come back to the let's come back to our discussion for today. All right, so let me get started with what we see in the industry, like how or the origin for the automation, right? So there has been quite a while that we were all sitting on the waterfall. There's a lot of innovations that people have done with nonlinear automations, especially in 90s and early part of 2000s too, where there are only handful of tools. When I started my career, it was either you pick UFT, so which was used to be WinRunner at those days, and rational tools. So if you're IBM shop, natural choice is rational. If you're non-IBM, then you usually go with the WinRunner, right? So having said that, the test automation has evolved. A lot of different frameworks came in. Then Agile and test automation. Then with the DevOps being in there, leveraging automation there with it, on the continuous testing standpoint. But even with all those acceleration with the continuous testing, there are still some gaps, and there are still a lot of need for automation to go to the next level and to keep pace with it. But at the same time, the speed shouldn't compromise on the quality, and the testing has to be more smarter with growing technologies. Every year, there are a lot of new technologies coming into the market. And even if you see the release cycles, we always plan in a way that the QA gets sufficient amount of time to release and to test. But in practice, what you usually see is you only get probably 70 to 50 to 70% of what you originally planned. So that always puts a lot of pressure on the QA teams to deliver more in a very short amount of time. So if you look at it, the typical time where it's spent with the QA automation, in the QA automation, if you take any project historically, the non-AI based projects, you pick the tool, then you actually do set up a framework that has different components, where generic set of components based on the tool and the programming or language bindings that you pick, then the project specific bindings. With all that said, you set up the framework, then you do the manual test case design to establish the validation points and the acceptance criteria. Then you actually start doing the automation scripting. Let's say, for example, take Selenium. You pick the project bindings, be Java, .NET, one of those. Then you pick the generic framework aspects, then the project specific aspects. Then you start doing the automation scripting, building the module specific, POM related, module specific type of scripting. Then the actual test cases. Then you test them, unit testing, then cross-browser testing, then goes on forever in terms of ongoing maintenance for each release, each change, each code check-in. But if you look at the time that we spent, if you at the end of the project, or maybe a set of test cases that you originally planned to do, if you take the time that you spent, about 25% goes towards framework design, about 10% for the test case design, and the scripting and unit testing would usually take about 40%, and then execution, making sure you run across different cross-browser compatibility and all that, would be about 25%. Then you keep spending about 10 to 25% on each cycle on the maintenance. So the biggest parts are framework design, the script design, and the maintenance. That, as you could see, is a significant time in the test automation cycle, right? And you have too many choices, different tools, tier ones, tier twos, and then open source, right? And then you have different programming languages depending on the tool that you choose, and different applications, technology complexities, all of that. And also the roles and expectations of a tester has also changed. It's significantly changed to an extent where tester is expected to do a lot of automation, and there are varying technologies, and testers are always confused what technology and what tool to pick on and to keep doing the test automation. So is that model sustainable? And especially with the DevOps coming in, and there is a lot of push for testing and test automation to be part of the DevOps cycle, making it continuous testing, and to be in pace with the entire release cycles and the deployment cycles. How practical is it, right? So with all that said, and with the digital disruption being going on, it's always a question on how much to test and what is the sufficient a point wherein the we have to make sure where the code breaks are not there with the high frequent releases, and ensuring that the right amount of test coverage is always in place, right? So with all those in place, it's always a question around how much to test and how frequently to test, and when and where to test, right? So automation has always been a key, but having the traditional automation is not really helping to the extent that we really want, right? So the quickest solution is to look at AI, especially that being a newer technology, and to see what AI can do and how AI can help the overall software testing lifecycle, and predominantly the QA automation, and what miracles that it can do, and how much impact will it have. And that's where we'll spend rest of our 30 minutes to go to learn more about it. Before we get started, a quick 30 seconds poll. This time it's only one question, and again you get 30 seconds to answer this as well. 15 seconds more. And 5 seconds more. It's only a quick question about yes or no. And that's it. Let's see the results. So about 20% said yes, they know how to do it, and about 80% said no. It's almost like a Pareto analysis, right? 80-20 rule. So 80% says no. So let's spend rest of the time in terms of knowing how and where to do. Okay. So let's jump on. So let's look at it. Let's look at it from a way where AI has been helping. So again, let's not talk about what is AI, different components of AI, machine learning, deep learning, all that. Let's focus strictly on how AI is going to help. What are some of the improvements that AI is bringing, especially with with the software development lifecycle as a whole, not just the software testing lifecycle. Although I'm going to talk about it in the next slide. So if you look at it, biggest phases are the first phase. Typically, we get test planning. Sorry, the entire project planning, the software in the development lifecycle. We have seen AI helping, doing quite a lot in the planning stage itself in terms of identifying the user story patterns, so that the project teams will have an idea about what to group, and how to prioritize them, assistance with prioritization, and also a lot of dependencies and suggestions based on some of the production based clusterings and production based impact analysis that is being done. So those inputs from the live production analysis would get into the product backlog and the user story patterns, so that the product owners and the scrum masters could facilitate that feedback into the system. And it also have, we have seen certain, startups have doing a lot of work in this space, where they're also identifying the risk categorization right from the beginning at the time of user story patterns itself. So you wouldn't need to manually need to do, or at least in combination of manual, you also have a lot of assistance from the live production analysis. And in the second, design and development stage, there are a lot of tools that came into the market, deep code, SourceD, and all those, which are actually, got started with automated unit testing, code generations, scanning through the entire static and dynamic analysis, and helping you with what's actually been happening, and to be more productive in terms of developing code. A lot of assertions, and a lot of additions, and a lot of code, common templates that can be generated. That's a significant productivity improvements. And on the test, identifying defect prone areas, RBTs, we'll talk about in detail in the next slide. But deployment is another area where, especially sensing the right environments, the success with the production, primarily with A/B testing and the canary and green deployments, and also monitoring the production logs and giving smart suggestions for the planning stage. All these has been quite a while, and some of these, to my surprise, is far more matured than what we actually think. And those a lot of startups and including Marlabs in this space has actually been spending quite a bit of time on how do we improve the overall software development lifecycle, both from efficiency point of view as well as from individual productivity point of view, leveraging AI. So these are some of the areas that we have seen where AI has already started its footprints and bringing the efficiency in the software development lifecycle. But speaking in specific to quality assurance and where and how AI fits in, let's go phase by phase. To start with, test planning and design. In the test planning, we have seen, based on the user story patterns that are developed, the test case design suggestions and the coverage suggestions have come. There are tools and the algorithms that are in the market available that can actually scan through the application and then suggest you what different patterns that you can analyze and different test cases that can be developed. And also leveraging NLPs and NLGs, the test case, the script generations, the test coverage suggestions that you can talk about. And then significantly on the on the test execution, there are quite a bit. You would have seen Google has recently released a lot of different next version of their algorithms and APIs where you can use them for AutoMLs and all that, for various types of combinations that you can leverage in testing, primarily with the visual comparisons and the document comparisons, doing A/B type of testing, and also some proprietary and custom startups doing risk-based testing type of custom algorithms. Significant improvements in the mobile, web UI, and API test executions. Combining with the traditional ways and leveraging these suggestions from the AI is actually improving the test efficiencies and the overall effectiveness. I would say probably about 40 to 50%. That's what some of the stats from some of our implementations have actually been seeing. And getting into test management, quite a bit on the identifying the data patterns right from production, and the defect patterns in terms of preventions and some root cause analysis and all that. And in addition, it also has been helping the overall life cycles from the production validations and assisting users with UAT and some user analysis and productions, the right set of scenarios, the smart maintenance and all that, right? So these are either some of the expectations, but at the same time, AI has already been helping in this. And to be more precise, when we go to the next slide, here is where I would say what is the level of maturity and the level of automation that is currently there, and what's mostly reality and some of the myth. I've seen Forrester report. She's actually taken some of the information from the Forrester report and also some of the customer implementations that we have done. Here is where I think I would say it fits significantly. So let's go one by one. I would probably start with the automated test case generation. We have tools in the market right now like Autonomic and Functionize that can actually read your manual test cases that users have written in plain English, and those can actually generate the test automation scripts without actually doing any programming. And in fact, this has been part of our Marlabs AI-based test methodology as well. But a significant improvement has been done. The level of automation is significantly high, and it's also mostly reality. So the testers wouldn't need to really sit and do a lot of scripting, mostly on either Python or Java. These tools have been able to take the manual test case output and ability to convert them. So the languages or the tools that are being used behind the scenes or the NLGs, the natural language processing and the natural language generations, right? And the next one is, if you take the visual testing, right? Visual testing is a lot that is happening. 10 years back, I have written a program myself in Java that can actually compare two images, taking pixel by pixel comparison, and that tells you if there is any difference between two images, right? But if you leverage deep learning and the AI machine learning right now, they do the same job, but they do it more effectively and more accurately with more precision. So what that precision means is, the programs that we used to write traditionally is, if there is a change in the image size, or if the form factor differs, right, the comparison wouldn't be passed, because the pixels would be different even though it's the same image. But by employing deep learning and the machine learning algorithms, that wouldn't be the case, because they know where to fail, and it has the intelligence on when to fail, and it actually considers those machine learning and deep learning reasoning to accommodate such tools. The apply tools, one of the prominent in the market ones right now, they're very known for doing this in terms of precision, in terms of no false positives and negatives, right? So significant improvement, efficiency and accuracy. And if you look at it from a predictive engine standpoint, Marlabs has product called MAdvisor. So what we do is, it does the churn analysis and predictive and analytics engine built into it, takes the data into it, and then it has the ability to predict what it can do, what types of churn analysis, some sort of predictive engines based on what we currently have. And how we are doing it? By taking the machine learning algorithms, like the linear regressions and some reinforcement learnings in terms of how to and what to and all that, right? So we take the data sets and we leverage. But the point is, these things would have been done manually in the past too, but with a lot of time, and with a little less accuracy, or significantly less accuracy than how AI and machine learning can do now. And these are significantly there. And there are, the Marlabs MAdvisor is comparable to IBM Watson at the similar space. But there are plenty of tools in the market that are coming in that does all this in a detailed fashion. And similarly, on the defect management, there are a lot of patterns that you can analyze. You can identify what is a defect prone area and what is not. Earlier in the past, we used to do based on the significant density. If there is an area that has higher number of defects, then you would think that that's an area to concentrate. But now you have far more areas. You can employ the AIOps and keep monitoring, with tools like New Relic and AppDynamics, and get these stats, and also compare with what's going in the real environment from a web app standpoint and from the network app standpoint. Combine all this and get a granular view, and then do the defect management of it, right? So that clustering is significantly helping. API test case generation. There are a lot of tools like Parasoft SOA API that can generate and does all the work behind the UI, and then get this stuff done in terms of API generations. Test data generations. We have built custom algorithm that can actually monitor the production and then gives you the real usage of production and real users, right? So there are significantly far more achievements that are happening right now in the market, and that's actually helping out, bringing the overall efficiency. So if you look at it from a reality standpoint, everything that I've spoken so far is in real, but have they matured to the extent that everyone can use? That depends on your expectations, but there are enough examples to get started and start leveraging in your own day-to-day life to be more productive than what you are today. So to that extent, I would say definitely yes, it's mature to an extent where it would help you and take you to the next level, or save some time and be more productive and focus your time elsewhere where only you can do and not the tools, right? So to that extent, it is definitely out there. And even if you look at the test lifecycle, optimization, there are tools that can actually scroll through your entire application and then tell you what is working and what is not working. I can give you even an example. Microsoft has recently released the test impact analyzer, TIA, right? That is directly coupled with Azure pipelines, wherein it helps you to determine what test cases you would need to run. So if you have 1,000 test cases, it is practically impossible to run all the 1,000 test cases on each deployment. So what this Microsoft TIA add-on on the Visual Studio helps you is, it will, based on the code check-ins and the code that you have, it identifies the impact areas and it associates those with the test cases, and then runs only those set of test cases. It also has the fallback mechanisms in place to run everything. But I'm bringing this as an example so that you can actually look at it, how you can improve the overall optimization. And I've also seen tools and the clustering algorithms that are built for data-driven testing, the data quality testing, all that, right? All those have been in place to make it more effective. What is mostly on the myth side is the customer sentiment analysis, although that's been coming up significantly. The what users can visually feel, even though neural networks are actually spending quite a bit, and the maturity is going on significantly, but the level of automation is high, but there's still a long way to go. With all that said, you might ask what different algorithms are being used, right? There are plenty out there, but I have picked up what we are practically doing, what some of our customers are doing. The natural language processing and NLGs are really helping in the test case design and the scripting parts. The supervised and unsupervised learning, which is the bigger two components of the machine learning, right? Those have been helping in a lot of different examples, right? In terms of defect patterns, clustering, executions and maintenance, object changes, code generations, and keeping an eye on what's happening in terms of object changes and all that. Those algorithms are being used. Then linear regression, which is part of the supervised learning that happens. Fuzzy logic algorithm, especially when you are doing object identifications, you would need to know which object works better versus over another object. You have different selectors like ID, CSS selector in the test automation, right? Which one does better? What is the probability of looking at two different elements? Which one to pick? You can use the fuzzy logic algorithm in terms of what chances that you are seeing over a period of time. Then k-means clustering in terms of data mining and data suggestions, patternizing different clustering. One of the examples that I can throw is, when you have a set of columns to be validated in ETL transformations and all, if you were to pick and choose, instead of validating maybe a billion rows of data, you can actually create different clusters based on the selections and the number of clusters that you can form on various columns that you have, and you can leverage that. And the algorithms, there are a lot of Python algorithms built in, and they're all built on the k-means. Then ranking, node ranking, in the session rankings in terms of sentiment analysis, page object rankings and all that. And similarly, computer vision for doing a lot of UI UX and image recognitions and comparisons. And reinforcement learning, that's been quite significantly in there right now, primarily in the automation maintenance and the test case design decisions and path traversing for the coverage suggestions and all that. And finally, neural networks, that's been making a significant case on the dynamic executions handling, more, that are ideally otherwise not being combined earlier, right? So there are a lot of algorithms publicly available. You can pick and choose and start executing, or you can lean on tools that have actually infused a lot of these in their tool sets. But if you look at it, this slide, we have seen this earlier, traditional automation, but with AI and ML, the time that we are able to save with test automation, right? The first box, framework, is now not needed because each test case can be independently designed with no framework aspects and maintenance around it. And then the manual test case design is optional. If it's not already there, if you want to build it, you can actually build it. Otherwise, it's optional. Then the automation scripting with NLG and NLP completely taken out. You wouldn't need to do that. Maybe some cases you might want to do some false positives and then correct them. But as such, the scripting can be eliminated. Then the execution and unit testing, again, not needed or is optional just to make sure for your own comfortness. Then an ongoing maintenance, it's also not needed. So with that said, if you look at it from an overall lifecycle standpoint and in the percentages, the 25, 40, and the 25 that we spoken earlier is significantly down, and you can actually achieve 50% more productivity. And the Marlabs AI-based methodology is also built around the same. What we used to do earlier without AI is now with AI, you can actually essentially bring the test automation into the lifecycle right from system testing itself without waiting until the functionality to be stabilized. That helps you to do a lot of in-sprint automation versus a sprint delay automation. And if you look at it from an AI maturity standpoint, there are 6 levels. I would say level 0 to level 5. The level of automation increases. At the same time, the AI assistance is also increases. And right now, a lot of tools in the market are mostly around level 1 and 2, and they're achieving towards level 2 and 3. But what we have practically seen with different algorithms that we have seen and different tools that are in the market is, typically what it used to take about 4 hours to create a test automation script is now down to 0.5 hours, because all you need to do is to set the validation points in place or the manual test case, and everything else is taken care. The tools or the algorithms, these tools can take care of the script creations, and the maintenance. Same thing, what it used to take about half an hour on each test case or an object change can now be taken care. If it's a business logic change, it's a new requirement as such, and you have to rescript it. It falls under the first category. And you can have higher capacity. You can use resources time on something that is more productive, that only users can do, and the time for regression can significantly come down. And with all this, the future velocity can be higher. So with the same amount of staff, you can achieve more, right? With all this said, although I have seen significant maturity over last 2 years, there are still some hesitations that I have seen with our customers as well as some of the users in the forums, right? Some of the hesitations that I've seen is people think that it's difficult to get started and should have deep knowledge about AI, deep learning and neural networks and all, which is not the case. You don't need to get started all the way and you need to learn anything. It's just that you pick and choose where you want to address, and there are things that are already available. We wouldn't need to sit and write all these algorithms or the code. You can choose tools that have infused these technologies, or if you wish, and if you want to customize, you can pick something that is readily available, call those APIs, or take the algorithm and just customize for your own needs, right? But it is not difficult to get started, and you wouldn't need to be a master of AI and all these algorithms to get started in leveraging an AI. And you can also tap on to companies like Marlabs to help you, if you have the desire to get started and intend to get started right away. And second, you need to develop custom algorithms like test automation scripts. Not necessarily. You might need to do some customizations, but you can certainly tap on to what is publicly available. And AI test cases are not debuggable to ensure accuracy. They are accurate to an extent because it's all built around the data that you feed in. So the accuracy depends on what you are feeding in. So that's something that you wouldn't need to worry about. You wouldn't need to retest something that's already tested by AI. And should wait until AI becomes matured? Definitely not. It's like in an Apple iPhone. Do you want to take an Apple iPhone 1 versus wait for 10 years and get Apple iPhone 11, right? Or wait for 10 more years to get Apple iPhone 20. So there is no end for it. It's always better to get started with what we have, and the technology matures, and we all mature along the lines. So I would always say that take the best out of what you have and get the better productivity what you can, and then keep moving on, right? And limited customization compared to non-AI driven technologies and frameworks. Of course, there is a lot of flexibility you get with frameworks, but you would also need to spend, in terms of dollars and in terms of commitment to do it. So what would work? And as you keep working more and more with AI, and the AI will also get matured, and that will eventually help you, right? So that's the take around it. With all this said, my take on this, on the future of API, is AI is certainly transforming QA more than any other phases of the software development lifecycle. Eventually, I get this question a lot, that does AI replace testers? I don't think so. If it can mature to an extent where we don't need to write any scripts, we don't need to test anything, we would certainly reach a point where we wouldn't need to even develop anything or code anything, right? So with that said, it goes back to the fundamentals of computers, existence of computers. We lose in some area, but we gain in other areas. What we need to do is embrace what is coming into the market, let's take the potential of it and then see how best we can reskill ourselves all the time. So when we are prominent in the market in terms of the cutting edge technologies and start leveraging, that should never be a concern. And there are a lot of advantages with it, in terms of, if you look at it from an optimization standpoint, we create a lot of different technologies, that are coming in, but we can create and adopt different use cases from the production, make it more effective. One of the challenges in software testing is always, how do I make it production-like, right? You can leave that part to AI and let it recommend you on what is that production-like meaning. And it can also, get you the production type of scenarios and build the test cases. It is there in the current market to a great extent, but it will eventually be there to a great extent. And I'm sure about it in the next 2 years. And the AI ops has been helping quite a lot on the high risk areas and the production access, what is actually in the production that is not helping or would need a lot more attention. And those have been feeding back into the user analysis and the use case point of views, and that's happening, and that will more mature. And we can be even more optimize our test efficiencies by doing a selective regression and by doing continuous testing on each build and enabling the automated test scripts to run on each build. So that way we can eliminate the defects early in the game without actually waiting until they pop up in the later cycles. And AI powered continuous testing can recognize change controls more effectively and predict failures. And I'm hoping that the failure prediction will significantly improve a lot more, because we right now have a lot of data, and I've seen very few organizations who are not using test management tools. So every organization that has the test management tools and the production production monitoring tools have the data in essence. So all we need to is to tap onto that data and then run different models to make sure we get a right sense out of it, and we can greatly improve the accuracy. And I'm sure in future that will have a significant impact on it. And our results have already shown that the coverage can be increased by about 40% by tapping onto AI and the models. And automated testing cycles have already brought down to 50% by realizing, it's based on probably, I would say, 20 plus implementations that we have already done and seen. And that those numbers will only grow significantly. And personas based couple testing and user experience is something some companies are significantly making, but that's something we will see a lot more in the future as well. And some of the potential players in the market, Atomic and Functionize are two that we are partnered with. Having said that, there are a couple others in the market as well who are significantly contributing to software development and software testing in general, and making a difference from an overall application development and testing standpoint. Together with our partners, and Marlabs is here to do help anybody who needs some help. But having said that, we have practical experience in doing a lot of this, and everything that I mentioned today is based on a practical experience on leveraging different algorithms and different tools in the market, and what we also built internally. These are some references and sources that I have used for this webinar. And at this time, I'm going to open the forum for questions. We have about 3 to 4 minutes, and let's use the time to take any questions that we have. So you can actually post the questions in the window that you get there, and I'll get to see them. I'll do my best to answer those now. If there are any questions that I won't be able to answer today, I will answer them in the couple next couple days, and we will reach out to you. And if there are better answers than what I've done today, I'll also reach on those as well. So all yours, time for question and answers. So I have a few that are coming in that I could see right now. The first one I see is, I think we have already spoken around it, is it the right time to start leveraging AI, in the QA? So I would say yes and no, because you always need to wait. There are always two ways. Either you can wait forever and see what best coming in the market and wait until the expectations are coming, or tap onto something that are already there and make sure you start leveraging them. For example, as I said, in the test automation space already quite a few um, we have quite a few improvements already done in terms of test case scripting. You wouldn't need to do the scripting for most part, and the script maintenance and all that, right? So those are some advantages you can already start seeing it, and those would be nice to tap on. And the others are in terms of the image recognitions, test comparisons and all that. So there is no point in waiting. Keep taking what you're getting and then get started with those. So that's my honest take on it. And the next question is which algorithms to start with. We have spoken quite a bit there. So that depends on what you want to achieve. Each model, each algorithm is meant for something. But rather, I would say it's not to start with which algorithm. Your approach should be what you want to achieve, and where and what you are looking for, right? Are you looking for more questions around, are you looking for more around maybe a defect prevention or a defect management, in which case you would need to probably look at some clustering algorithms, k-means and all that. Rather, if you want to look at more something that can read and interpret and then help users, right? In those cases, you probably need to look at some NLGs and NLPs for that. And rather, if you want to predict something based on what you have, then you can tap on to something like linear regression, such algorithms. So it all depends on what you want to achieve and what you really want to do. Okay, then can also can we leverage AI with Selenium? We have a lot of Selenium scripts. Definitely yes. Selenium does not currently have any inbuilt algorithms as such, but you can build your own. You can tap onto the data and you can see the failures and you can see what might come in and all that. So it's definitely no need around that. You can definitely start leveraging AI there. And the last question that I'm taking for today is, does AI replace automation engineers' job since there is no scripting or maintenance required? Certainly not. It's right now the maturity is so much we still need, but eventually all these companies in the market, different products, the goal is to leverage the AI in to a great extent. So if you really look at it, the ambition standpoint, maybe eventually that's the goal, to limit the not the users, but rather the increase the footprints of AI. But at least in the near term, in the next 5 to 10 years, I would definitely say that AI would not replace the automation engineers, but rather augment them in terms of reducing the product, increasing the productivity and reducing the time that user or engineer would need to spend. So you would still need to have this, address the false positives, and some applications, there are no tools in the market that can actually address such, right? Like desktop applications and all that. So definitely there is a need. It's not going to take away. It all depends on how we are going to leverage and how we increase the overall effectiveness of our day-to-day job and productivity of our job. So with that said, I'll conclude the session now. We are right on time, about 45 minutes when we started. If you have additional questions, please feel free. Send those questions to myself, Siva, as well as Ram. The email IDs are listed here, and our teams, webinar teams who organize this, they will also reach out to you around it. So thank you so much. I appreciate you listening to me and for this webinar. Please feel free to reach out to me on any other questions that you have. Once again, thank you, and we appreciate all your time. Have a good evening and good afternoon, and across the time zones that you are. Thank you.